Hello and welcome back. In inferential statistics, let's try to understand what is confidence interval. The confidence interval generally will have a range and a probability, a percentage. So, if you want to understand confidence interval in simple terminology, when some contestant is contesting in an election, the exit poll guys will tell that this guy may win with 13,000 to 17,000 majority. We are 95% confident. There are three numbers there. The range 13,000 to 17,000 and 95% confidence score. So that's actually called as confidence interval. So the confidence interval will have a range and a percentage or a probability percentage. So let us try to take one example here and try to understand it and use our central limit theorem to find out the confidence score. So the example is like this. A sample of 36 apples were drawn from 2 lakh apples population. So here the population size is 2 lakh or 200,000 and we have chosen 36 apple sample and the sample's mean weight is 112 grams and the standard deviation of the apples is 40 grams. What I mean by standard deviation? When you take any random apple from the 36 apples, it's going to be around 40 grams far from mean. It's an approximate number. You shouldn't be taking that seriously. That means what? When you take an apple from these 36 apple sample, the weight of the apple may be between 112 minus 40 and 112 plus 40. 72 and 152. So that is general estimation. So standard deviation gives you that kind of a general estimate of your sample or population. So here the 36 apples we have chosen and the mean is 112 and the standard deviation is 40. If data is normally distributed, the essence, whatever I spoke right now, holds very true. If it is not, it may oscillate a little bit. So what we need to find here? What is the probability that the 200,000 apples mean weight is going to be within 100 to 124 grams? So we have one sample and its mean weight and its standard deviation, and we need to find the probability of 200,000 apples being in the range, the mean of 2,000 apples being in the range from 100 to 124. So here in the confidence interval we have got the interval, but we need to find the confidence score. So the problem statement, in this problem statement we have got the confidence interval 100 and 124, the range, but we need to find the percentage, right, the probability. How much confident that the 200,000 apples mean weight is going to be in 100 to 124 range. So need to find what we have here: sample size, mean of the sample and standard deviation of the sample. What to do? We actually need to find the probability of 200,000 apples mean weight is going to be between 100 and 124. We have very little information, so we will use central limit theorem because we are trying to understand 200,000 apples population's behavior by looking at a sample, or we are trying to infer the population's behavior by looking at a sample, 36 apple sample. So let us assume, to use central limit theorem, we need to make some assumptions. So let us assume that we took many samples of 36 apples from the 200,000 apples population. And the second assumption we are trying to make is all the sampling distributions mean is 112 grams. That's nothing but, suppose that we have chosen many samples here and then we have calculated means of all these samples and then tried to take a mean of all these means, and that mean is 112 grams. Suppose that, because we have only one sample and we are doing statistics. When I say statistics, it is approximation. So the approximate mean of all the samples can be, closer to whatever sample we have, right? So we are just assuming that all the mean is actually 112 grams. And then the third assumption is that the population's standard deviation is also 40 grams. Right? We have got only one sample, and that sample standard deviation is 40 grams. So best approximation for the population is only 40 grams. What we have is what we have. So we are trying to use that and try to find out the confidence score. Right? When you actually take many samples here of 36 apples, the sample means are going to be normally distributed. We know that from central limit theorem. So let us try to see what else we can do. When we actually know that the means of many samples is normally distributed, what we need to find? The mean of the population is going to be within 100 and 124. That's what we need to find, right? So we know that all the means of many samples are normally distributed. If we know the standard deviation, we can actually calculate how many samples are going to be within 68% and how many samples are going to be within, how many means are going to be within 68%, how many sample means are going to be within 95%, and how many samples means are going to be within 99.7%. So our goal is to find out the standard deviation of all these sampling distributions, which is nothing but standard error. So let us try to see how to calculate standard error. Standard error's formula is the population standard deviation divided by square root of sample size. The population standard deviation, we have assumed that it is 40, and the sample size, we actually assumed that many samples were taken, the square root of 36. So the sampling distribution means standard deviation is 6.67, which is nothing but the standard error is 6.67. When we know this, we know that from normal distribution concept, 68% of the data is going to be within one standard deviation away. 95% of the data is going to be within two standard deviations away. Let us see on this particular example how many samples are going to be within 95%. So here I have actually taken the mean, subtracted the standard deviation, added standard deviation. So 105 grams to 118 grams, there will be 68% of the apples or 68% of the samples means. Okay, and 98.66 and 125.34, two standard deviations away. That means 95% of the samples you chose, 36 apples you chose, are going to be, the means are going to be between 98 and 125. So what we need to find? 2 lakh apples mean is going to be between, the confidence level that, it's going to be between 100 and 124. So this 98 and 125 are kind of close, right? So roughly speaking, the 2 lakh or 200,000 apples mean weight may be around 98 and 125. We can say that it is 90. We are 95% confident. So the confidence interval 98 to 125 has got 95% score. So now we need to find out the exact score, right? Exact score of how much, right? The score of the range between 100 and 124. So let us try to see how to do that. So the 124 is 1.8 standard deviations away. How did I calculate that? For 124, I calculate the z-score. What is z-score? Z-score is equal to x minus mu by sigma. What is x here? 124 minus mu 112 divided by sigma is 6.67. Right? That's what I calculated. So it is 1.799. I rounded it off and I have got 1.8. So the 124 is 1.8 standard deviations away, plus 128 standard deviations away. Similarly, the 100 is minus 18, minus 1.8 standard deviations away. What this means is, when you look at this z table, at 1.8 how much probability or how much area under the curve it covers. So we know that the normal distribution is going to be like this, and the area under this curve is 1, right? 1.0. When I say 1.8 standard deviations, that's going to be after the mean, right? The mean is, here mu, and then 1.8 standard deviations is going to be somewhere here. 1.8 standard deviations is going to be somewhere here, right? That area under this curve, till here, right? Till here, the area under this curve is actually this much percentage, 96.41. So let me take another color and write it down. So the total area till this 1.8 standard deviations is this much, and that quantification can be got from the z-score table. It is actually 0.9641. Okay, this is actually the probability. You can actually say in terms of percentage as 96.41%. Okay, so it is from beginning till 1.8. The area under the curve we need is from minus 1.8 to plus 1.8, because we wanted to see the range, the probability percentage for the range 100 to 124. That means minus 1.8 to plus 1.8, right? So we need to find out the probability or the area under this part from minus 1.8 to plus 1.8. Okay, to find this out, what we need to do is we need to find this part from mean to 1.8 part. If we can find, we can double that, right? If we can find this area, right, we need to find the area under minus 1.8 to 1.8, right? So we can actually double that, like that, right? Double that, and then find out the probability. So to find out this area, right, what we can do is, the total area under the curve is 1, right? So if you split it into half, this is going to be 0.5, right? So what we will do is, from the total area till 1.8, we will subtract this half area. Then we will get this area. So we will double that. Okay. So if you subtract the 0.5 from this number, let me take another color, 0.9641 minus 0.5, that's going to be 0.4641, right? And then you need to double this, because this area you found, and we need to find the area from minus 1.8 to 1.8. That means we need to double this area and find out the total area under that part. So into 2 is nothing but 0.9282, which can be expressed as 92.82% confident that the mean weight of the population, the 200,000 apples, is going to be between 100 and 124. So we are 92% confident that the mean weight of the 200,000 apples is going to be between 100 and 124. So that's about the confidence interval. Thank you.